All right, this is our review session. So I don't have much of anything planned. So I will just be relying on people's questions for figuring out what we're gonna do for the next 50 minutes.
How many points are in there?
I forget. Let me read its availability.
See how hard it is.
Huh?
See how hard it is.
Huh?
Alright. We'll see you outside. Rob. Right, I'm probably gonna break a quick.
It's pretty easy to put down the stairs.
Oh, he's gonna toast me. Are you kidding me? Can I at least like know his routes? Not a at least yard it. Straight up one.
Yeah.
I'm not like, right. What? You're talking about. If you give me the route, I can forget.
There are 108 possible points on this exam as well.
Oh, I thought you were gonna say that.
Will the format of it be similar to what we've already experienced, or like the same as the end of the last exam with the strategy?
I would say that either of those kinds of questions are valid, so you should prepare for both.
Like breaking down each part.
Know everything at an intuitive level and reasonably at a technical level. I'm not gonna dive super deep into the technical level, like I won't ask you to write a bunch of code about a single design pattern. I might have you do something that is about the scope of the duck superclass off of the first exam. But that was only a few lines, so I only want there to be a few lines per question, because if I'm gonna really hone in on one thing, then I expect to have that level of depth for each of the patterns. So the code depth that you need to know is quite shallow. But I would say no structure more than code. That is the hint that I can give.
When we're talking about the singleton pattern, what do you mean by kind of just like thread safety and how we can enable thread safety?
Yeah, so we use the keyword volatile as we did this to basically say that we only want to let a single thread in at a time. Because if multiple threads can access that method at the same time, then by the time that what creates the singleton is we're querying if one instance already exists, not if one is under construction. So if you think about a longer term thing than just the couple milliseconds it takes to instantiate a class, if there were a building constructed, let's say we only want one building to be constructed in this entire lot. But when we query, does a building already exist? We're not gonna look around and see, are there any under construction? We're gonna say, is a building open that I can walk into that's a fully completed building? So now the manager of this lot says, yeah, you can start a construction over there. Yeah, there's no buildings yet. Yeah, you can start a construction over there. Yeah, there are no buildings yet. You can start a construction over there. And then only once the first building is complete, now that manager says, oh no, a building already exists, but 12 more are under construction. And the manager doesn't have any authority to stop a construction. So all of those are gonna complete, and we're gonna have 13 total buildings when there's only supposed to be one on this lot. Because the way that the manager operated is there a building already constructed, yes or no? And that's exactly how the singleton works. It's asking, is there already an instance of this object, not are we in the process of creating an instance?
Couldn't that be exploited a little bit, like?
Exactly.
Like, just have, like, someone does the project both simultaneously, the manager is gonna check for that.
So that's why we use the volatile keyword. That's why I gave you a couple different solutions to that problem of combining the couple of things that I talked about as well. We have a couple of solutions for how to actually make sure that only one instance is under construction rather than one instance exists. Because one instance exists is the default. And we see this a lot in more advanced computer science. There's a lot of thread safety concerns. It's something that you'll just find yourself thinking about whenever you make something, is this thread safe? And this is the first time where it's really part of the design. A singleton's design is all about there only being one instance, so we really need to concern ourselves with how can this be exploited if we want to truly guarantee only one instance of this exists.
What is the dependency invasion principle?
The dependency inversion.
Inversion,
Yeah, so let's see, where did that show up? I wanna talk about it exactly how it was mentioned and not just give you an off the top of my head.
It was mentioned in the abstract and the factory stuff.
Yeah. Let me pull that up real quick, just so I can give you exactly. Remember it. So. In general, at its most basic form, the dependency inversion principle just basically says rely on abstractions, rely on interfaces. Don't rely on concrete classes, don't rely on the fact that you could code something assuming that the object is of a particular concrete class type. That means that you need a lot of ifs for all of the possible concrete classes that could be part of that interface. And then that also creates a modification issue. If you go back and add an additional subclass to that interface, then you need to go back to where you're doing that if, else if for each one of those concrete classes and add another one. So you have to go back and modify an existing class in order to add the logic for how do I handle that particular concrete class. So the dependency inversion principle is basically saying if you can rely on abstractions over the concrete classes, you let the object tell you what type it is. So if you say, the example in the factory pattern is we had a high level component that was a pizza store and a low level component that was a pizza style. If we let the pizza store tell us, coming from a pizza store, we have a cheese pizza. Now we know exactly what sub method to call because of that class. We know that in order to implement this interface, there needs to be some method in this pizza that does this thing. Rather than making a big, large block of if, else if for each type of pizza, we're going to basically say, we know it's a pizza, we know it adheres to that interface, so we know it has this method. Let's just call this object method that we know exists, and we don't need to know its subclass or its concrete type.
Do you think there's gonna be like a lot of coding problems or like filling in code lines? Or is it gonna be the same kind of as 300 words? Less than or equal to 2?
So in general, with a 50-minute exam, I would say there's less than or equal to 2 coding sections or coding, reasonably sized coding questions on the exam. Because there are so many patterns to cover, there are however many patterns there were, 3 or 4 on this exam. 6 patterns. 6 patterns. So it's gonna be tough to ask you a coding question on all 6 of those. It's gonna be, I would either have to pick and choose which pattern to ask the question on, which is possible, that's something that I could do. But it's likely when you have this much content that needs to be covered, that the design of the exam has to be pretty surface level if I'm gonna hit everything. So there are some tricks that I use to make sure that I can hit things at a bit deeper than surface level, but also hit everything. And most of those, almost all of those do not involve coding. Because coding is an involved process that involves design, checking your work. And in 50 minutes, I don't really have time for as much of that. So I would say that if we're looking at the exams that I give as a whole, it is less likely that there are lots of long, deep coding style problems on this exam if I'm trying to hit all of the outcomes. The hint that I would give is know things again at an intuitive level, know how to apply things. So try to understand the applicability of the patterns. Understand the high level design of the patterns, like the components of the design. Don't worry as much about how exactly do you implement that. Note that there is 25% of this class's grade that is all about this project that has you applying the patterns in code. So if I'm trying to diversify your grade as much as possible to hit as many different outcomes as possible, it's likely that the exams aren't going to have as much overlap with the project if there are other things that I can ask questions on. I do think about and consider that when I write exams.
Can you talk about the prototype pattern and like the cloning?
Yeah, so prototype was an interesting pattern where at a very high level, what prototype is trying to do is save you the time of creating something from scratch. Rather, we're going to have a basic version of something already partially constructed, or have the logic to be able to say, we don't need as much information from the user as part of that construction. We can autofill portions of this based on, so the example that we used in class was the D&D monsters. If we have a generic armored enemy, then we can autofill a lot of the components of the construction without needing to get that from the user, without needing them as parameters as part of the construction. So we're just overriding the clone method, and we're saying now, how do we get a copy of that to be able to customize it? The other example that I gave that I'm starting to really like is the example of you're playing a game and you want to base your current character and character creation off of your last character that you made. You could select from a dropdown a stored repository of all of the characters that you've previously made, and that would autofill what the current character creator is. Rather than starting at a generic single point, you could start at the point of where your last character was. And that way you could make that character's mother or that character's son, or that you could come up with some way to start from something work that you've already done. Rather than redoing all of that work individually, you start from a copy that already exists.
When would you use it, the cloning?
So yeah, I whenever there's a large scale construction that you need to do, and you have the ability to save some of those steps. So a character creator is a great example of that. Whenever you're creating enemies in D&D is an example of that. I don't want to say too many more because reasons. There will be a section of the exam that has you coming up with your own examples of things. So be prepared for something like that. Be ready to come up with your own examples of where to apply these kinds of things. So in general, the high level is whenever you want to redo some of your old work without the input of that work.
Didn't see the slides for that, I might have missed it, I didn't see the slides for that, prototype.
They're not up.
They're not-
Oh, I'm not current on slides, that's bad.
It's only the prototype one that you don't have.
Save it. I mean, we could take it off, I'm just
That's what I'm wanting.
saying. You know,
Not a good idea.
just a suggestion.
The whole plaza agrees.
Yeah, you're very right. That's not up. That's my bad.
Not that I.
I would even do.
All right, prototype slides are up. That's literally how long it takes. I just have to remember to do it.
Well, there goes another bridge too.
How big will be drawing you about?
It's something that I could reasonably ask, so I would say understand the UMLs for a lot of these, understand the components and how the components are connected. Be able to describe each of the components at a high level. Diagrams of singleton and bridge. Let's go to refactoring. All right, so here's a great image to base off of. As much as I've said it already, I love Refactoring Guru for studying for these because they have a lot of really good examples. And it helps to just understand the pattern in general. So bridge was when we had different dimensions of change that we can apply to something. So we had shape and color, or I guess, yeah, shape and color as two different dimensions. And if we don't apply the bridge pattern, we need a subclass for each shape color combination. And the more variables we have here, the more multiplicative it gets. So if we had shape and color and size, and shape, a color and size and I don't know, drawings on it. So pattern. You can add a reasonable number of dimensions to this, and then each combination of them would need to be a subclass. And with the bridge pattern, we compose a shape out of a color. So we take one of the dimensions and we just compose. And we could do this in an abstract class form if there were multiple dimensions. We could have an abstract class that is a generic shape that has a composition of a color and a size and each one of those other aspects. And each one of them could have their own hierarchy. And now we have a bridge that spans multiple islands where each island is an inheritance hierarchy. It's just a long bridge. We have what, Key West? Something like that. So this isn't just confined to something that's this small and contained, but I think that helps you to understand it, to keep it in as small as possible. So the bridge is just a contains. And that allows us to split up the inheritance hierarchies where we add the number of subclasses rather than multiply the number of subclasses. And whenever we can break down a multiply into an add, we know that add scales way better than multiply. So that's basically the savings that you're getting by implementing the bridge pattern. looking at it, we have an abstraction and an implementation. So the abstraction was the shape and the implementation was the color. And we can continue to do this even if you have multiple different implementations, they just become multiple different fields in the superclass. Questions on bridge?
I forgot about the site, I'm gonna use it.
It's so good. If I were taking this class, I would live on this site. I did say that there's probably not going to be as much in-depth coding, but if you wanted to know about some in-depth coding, again, here's a pseudocode example that probably is more worth your time, but at the very bottom of this, you'll have a code example you could go look at to see how would you implement this, but you can think about how bridge and strategy are related, and to some degree adapter, which we're covering now. We have all of these patterns. The associated pros and cons are here, so you can really take a look at that. The how to implement process. Most of what I could ask you about the bridge pattern is gonna be on this page, or on this site on this page. So, spend some time reading through these pages, it's super useful. Next week, I'm gonna go through just a laundry list of the patterns that we haven't covered. And I'm just gonna be going through Refactoring Guru and kind of walking you through the logic of each of those patterns. Because honestly, that's good enough. This site is so good that a lot of what I would say or want to refer to is just already there on this site. So the other was Singleton. Was asked for, so. Have I mentioned how much I love this site? That's a great comic, that is a great comic. So yeah, you have a bunch of clients that may not realize they're working with the same object. Because it's static, so this is the room on the inside that has a bunch of different doors. So a bunch of people are working on the same object, even though they think they're all the only one working on that object. So that's hilarious. So the diagram, this is the simplest UML you have for a singleton. You have an instance, a single instance as a field. And then you have a constructor and getting the single instance, and the client basically just interacts with the instance. Now, we talked about how to make sure that that instance is thread safe in class. That's not really inherent in the structure here. You don't really include the keywords that you use as part of that, but just making sure that the associated keywords are there, we need to consider the thread safety of the singleton. What else do people have questions on?
Can you give us an example of like singleton, like how it's used?
How the singleton is used? Yeah, so. My go-to example of singleton is something like a particular database connection. We don't want people making changes to the database and pulling information from the database as things are being changed. So we want there to only be a single connection to that database at a time. So the way that we would implement that is when someone puts forth the request for the database, I want to connect to the database. The first thing we need to look at is there already somebody connected to the database? If there is, then we want to deny access to the database or put them in a queue that says, you're in a queue for access to this database, please wait. And then when the other person disconnects, we would be constantly every once in a while sending a query that says, is the database free? Is the database free? Or the other way would be a pull architecture that would say the database query or will let the first person in the queue know that the database is free once that connection is severed. And then that person is allowed access to the database. So that's my go-to example of a singleton, because we only want one of those. And that would be exactly how you want to access that. The thread safety portion of it is if two people very quickly to each other want access to the database, where the decision should we grant access and the actual granting of access may happen milliseconds apart. So you could write a program that says every computer on this network ping for access to the database at the same time at exactly this particular millisecond. So you would be susceptible to that kind of attack, where it's some kind of coordinated program that's sending the request all at the exact same millisecond. If it takes some number of milliseconds to allow entry, then you have a vulnerable system. Keep in the back of your mind, think about between today and tomorrow, was there some other computer science-y thing that you only want one of? What would that be and why? And then how would you guarantee its thread safety? Or what would happen if it weren't thread safe? What kind of vulnerabilities would there be?
What about like have you ever seen like the movie Clip
I have not seen that.
with with Adam Sandler? And it's just like a universal remote that can turn off.
Ain't no way.
Yeah.
Ain't no way.
You're not related to Adam
Ain't no
Sandler?
way.
I see the resemblance.
That's what I've been saying.
No way. As soon as you said it too, I knew. Oh.
The question is just how far back do you have to go until you're related?
That's a good question. Probably not too far.
But yeah, something like a universal remote that did, it's probably kind of the opposite problem. It's more like there are a bunch of different remotes that all control the same thing, and you only want one person controlling that at the same time. That'd be a great example of teaching children to work together. You have a bunch of different controllers around some kind of robotic claw. And then you let a bunch of kids all have access to the controls at the same time. And then the system is trying to figure out what is the net. If there's one kid trying to move left and one kid trying to move right at the same time, they cancel each other out. So trying to figure out how do you work together to accomplish a task. That's another good example of a singleton, where you only want one person controlling this at a time. As soon as multiple people are trying to control it, it's gonna be chaos. What else?
What would be difference between the abstract and the interface?
The abstract class in an interface?
Right.
Yeah,
Is it the composition and inheritance that makes decides like which one to use?
so it's very close to the same idea. An interface is just saying, in order to be a subclass, you must give me an implementation for everything in the interface. An abstract class will say, even if you don't implement, you can either override something. In order to be a concrete class, you need an implementation of every method that's defined in the abstract class. But the abstract class may implement some of those for you. So an abstract class is mostly meant as a code saving measure. Let's say that class A and class B both extend an abstract class. And these two classes do some method the same way. So class A jumps the same way that class B jumps. The jump logic can then, instead of being an interface where you'd be copying and pasting the same code, you move that code up to the abstract class. And now when class A or class B jump, since it's not defined in class A or class B, we look up the inheritance hierarchy for a definition. Since it's defined in the abstract class, we then do that. On the other hand, you can override it, and that way a subclass can do it differently. So you could define, rather than doing it the default way, and that's really the way to think about the implementation in an abstract class. The abstract class's implementation is the default. You need to change or redefine or override the default behavior to give it a new behavior in a subclass. But it allows you to save copying and pasting code, whereas an interface does not allow you to implement any code whatsoever. It's only definitional. To say, in order to have one of these subclasses, you need to define all of this behavior. I know, this one's a lot harder than 300 to come up with questions for, isn't it?
This is just understanding what.
Yeah.
Yeah, it's.
A lot of it is gonna be kind of individually reading Refactoring Guru. I would recommend that of just about everybody in the class. Just go through for each of the patterns that are on the study guide, read through this page. See how it describes. I think Refactoring Guru takes a very similar approach to how I would teach the pattern, as well as to the kinds of questions that I would ask on an exam, would be pulled directly from this content. Like, why would we care about this pattern? So what is the problem is basically the equivalent of that. What can arise such that we would want this pattern as a solution to that problem? The solution is, how do we solve that problem? How do we implement the pattern such that it solves the problem identified in the problem section? A real world analogy gives you an example to use, if I were to ask you for an example of something. And then the UML, if I were to ask you about how does the structure of the pattern lead to the solution? So if I wanted you to tie something like the text in the solution to the UML and the class design and how we implement this in code, that would be another reasonable question that I could ask about how does this structure lead to that solution? And then as deep as I would probably go would be to ask for some basic pseudocode or a very basic implementation of some of the simplest parts of the pattern. How many diagrams will we have on the exam? How many to recreate? It's a good question, probably at most 2. I would think that they would be somewhat similar to what I did with the strategy pattern, where I give you an example and I would say, does this adhere to the pattern? Or something like, here is a scenario. Draw me a UML using that scenario that adheres to the pattern and explain what it solves and why it solves it. So again, just a very high level understanding of applying the pattern. To me, that's what's important in here. I'm probably not doing something as straightforward as draw me the UML for this pattern. If you ever ask that question, you just go to Refactoring Guru and there it is. I don't want to waste your time on the exam as much. I want you to build your intuition or to query your intuition about why and how, as opposed to what.
What do you think the difficulty level for this exam compared to the last one?
My guess would be it's slightly easier.
This one's slightly easier than the last one.
That would be my guess. I'm known to be wrong about this. I say that and then people come to me and say, are you insane? That was way harder. So take that with a grain of salt, but if I'm taking these myself, I think that this exam 3 is slightly easier than exam 2. Exam 2 is pretty crunched for time.
Taking it with a grain of salt.
Which memorization is gonna be on this one? The other one, the.
Yeah, the other one did have a little bit of it, or some memorization. I'd be prepared for some, but I'm trying to cut back on that as much as possible in this class because memorization is something that you can always just look up. Sometimes those kinds of questions are needed if it's something that is important to the design of something. What is this design? Why does it work? But yeah, I try to wherever possible ask about the why and the how as opposed to the what. The what is a Google search, the why and the how is something that you really have to work to understand. What else can I answer?
What's a safety thread?
A what, sorry?
The safety thread, like for Singleton, it says be able to describe like a safety thread. Or thread safety.
Yeah, so thread safety is just saying that we want to make sure if something is thread safe, then it's safe from multiple threads accessing it at the same time. There is guaranteed behavior associated with multiple threads accessing it at the same time. That's not necessarily saying that it will allow or disallow multiple threads, but there is code for handling multiple threads.
You said safe from multiple threads, just interacting with it or doing what?
Yeah, so there's some kind of defined behavior if everyone in this class decides to query the singleton at the same time. It's thread safe if there is guaranteed behavior. The guaranteed behavior could be that only one of you, the first one, gets access. The guaranteed behavior, it could be you all get access and it's not really a singleton. It's thread safe if that behavior is defined and documented.
Could you go like, only some of you can because of weather conditions, and the rest you have to wait, right? Could you do that?
What was that, sorry?
Like, your conditions, some of you don't beat it, two ones don't beat it, you gotta wait.
Okay, I see what you're saying, that's,
But
yeah,
other conditions can be.
yeah. Yeah, we have some guaranteed outcome. Something's not thread safe if you say, all right, 5 things access it, what happens? And the person who wrote it just kind of goes, no. Or your program crashes, or,
Wait, that could be a desired outcome though, like, to when you access it, crash, program goes boom, I'm not gonna work anymore.
something like that, yeah.
But it's vulnerable.
It wouldn't be, but it wouldn't be thread safe. It'd be thread safe if that happens, it decides to shut down. That would be the defined behavior. It wouldn't really be thread safe and that it wouldn't handle it. But we would at least have some documentation that says this does not handle multiple threads.
Wait, so suppose like you make a singleton, it works, except two people access it, boom, that's the program and the output.
Well, they're gonna be denied. They're all gonna get back the same instance. The first person is gonna create the instance and then everybody else is gonna get back that same instance.
But like, could you somehow screw it up so badly that the singleton gets overwhelmed and then it crashes badly for everyone involved?
Not with how we're choosing to implement this.
Ah.
You could code it that way,
Wouldn't be a good idea.
probably not.
So in the real world, it would be like the company as a whole will decide what type of design pattern they're gonna use for each product. Is it-
Maybe. So yeah, your manager will tell you things like either here's the design that we're going for, Or even, here's the kind of implementation that we need to make this work. And you can do things like discuss that. There may even be meetings where multiple programmers get together to say, what are people's thoughts on the design? And that way, it's a group think and people design the solution together. It really depends on the company, depends on how important the project is, what the hierarchy is within that company. But especially for a junior developer, you're probably just gonna be told what to do. And the design is left up to people who are more important or making the decisions for the company. But I would argue that the more you know, even as a junior developer, you can start asking questions like, would it be better if we did this instead of that? It would take me less time to implement, it would be more safe in this is how you get manager level roles, or how you get your manager really mad at you if you know more than them. They stop feeling safe in their jobs when they realize their junior developer knows more about designing applications than they do.
That one you should start looking for a job.
Maybe. Or maybe the manager should start looking for a new job. It depends on the manager's manager. If they see that, oh man, it's this junior developer that should really be in a manager role, maybe it's the manager who should start looking for a new position. The next course in the sequence after this one that requires this is software engineering. And we'll talk a lot about how to work together with people. We'll talk a lot about how to interact with managers, what toxic workplace environments are like, how to navigate toxic workplace environments. There's a very big people effect as you start working. How to better say this? When you throw a lot of introverts in the same company and expect them to communicate with each other, interesting things happen. So we'll discuss what kinds of interesting things can happen and how to navigate that. Other questions? I do agree that there's not as much that we can go over here as there is in the more technical, be able to do all of this technical stuff. Here it is, here's the technical thing, here are the technical things you need to be able to do, but. We do have a few minutes left, if anyone has any remaining questions. Could disperse a few minutes early. All right, I'll stick around as people pack up, and if people think of any other questions, it's not like I'm cutting class off now, I'll stay here, you're welcome to leave if you have places to go and things to do. Or if you think of a question, feel free to ask.
So the second guided canvas for this technical.
Yep. It's up.
So that is to be accurate.
Yep. Whenever I write an exam, I pull directly off the study guide.
Oh, yeah. Well, yeah, the same. I use my.
Instructors take note of what it does, but.
Yeah. That's a you problem.
Because, so basically, this field and this method, this parameter.
I'm just listening to
I would say, since the root starts out as null and not at the value of this root, I would say this dot root equals root. Or I would take in no parameters that set the root to null. And that depends, in fact, I might even overload that constructor and that way people can pass in an existing root. Or they can say, I don't have a root, but I still want a tree. I would make sure that there is a way to make an empty tree.
So I should be tied with that.
No, I don't want you, I don't want you to.
I do agree with that.
Take your
As far
element.
as the design, if you're gonna require the user to pass you something, you should use that.
So then, okay, I still don't understand how I would use it right here, but I set the.
It's not really weird. And that's gonna set the field to be the value of the parameter. And that way it's being used as setting. But there should be a way to construct an empty tree with a no. So you would need to reload that construction.
Alright.